Okay, hello everyone. So today this is our second class. We will introduce second class to introduce building mechanical systems. Sorry. Let's see the any learning objectives for today. So we will first review concepts of energy and sustainability. We introduced last week, and identify sensible heat and latent heat, along with the related calculations. So we have homework one cover sensible and latent heat calculations. So please pay attention on that and understand essential terminologies in building mechanical systems, identify components of HVAC systems, and also understand the principles of comfort design in mechanical system. So now first let's review energy sustainability we introduced last week. So thermal energy is the unit of thermal energy is BTU, and the power of thermal energy is BTUH. So how about electrical energy? The unit is WH or kWh. The power is W or kW. So try to remember the unit of the and the quantities of energy, thermal energy. So if you completed homework one, you may get a really good understanding on that. So first one, how about C or water? C water, C concrete. Water is 1, concrete is 0.156. I know some of you write heat capacity of concrete as 0.2. So if you did that, I hope you can change it to 0.156 to keep consistent in this class. And then the heat energy equation is very important. Q is M by C by delta T. So we will use this equation a lot of times in this class, like when we calculate heat loss, heat gain for the building. So we may use this one, okay? So this is very important thermal energy equation. And next one, how to calculate the quantities of fluid. You need to know how to convert liter or gallon to pounds, because Q M by C by delta T. So the unit of mass is pounds. Okay, so if you find the given information, the gallon or liter, you need to know how to convert to pounds. Next one, electrical energy. So electrical energy converted to all kinds of energies, like mechanical energy, like scooter. If you drive the scooter, you have to plug in at night, right? And then daily you can use a scooter to drive to home, to school. So this is a convert electrical energy to mechanical energy. And also you can use electrical energy convert to lighting energy, get a light up on a lamp, and convert to heating energy. So plug in your heater, you can get the heating energy. So now let's see some terminology for fluid flow and pressure in mechanical system. So why we need to know that? Like, I'm not sure, have you ever visited mechanical room of for the HVAC system? So you can find the HVAC system have the two main components: air system and water system. So let's review some concepts of the air and the water. So air flow is measured in cubic feet per minute with the unit is CFM. So like how many or how much air supplied per minute in this room. So you can use CFM to measure that. And air pressure, inches of water column Let me introduce later. So why we use inches of water column to measure air pressure. And for water flow, GPM. So in this class, the second section is plumbing system. So in there, we will use GPM to measure water flow and water pressure, feet of head. Okay, so let's see why we use them to measure. I have this. So why the air pressure we use inches of water column? So I'm not sure, do you know the one standard atmospheric pressure? So this like this very normal air condition. So now we can breathe, right? So this means there's one standard atmospheric pressure. This very normal one, normal air condition. And that's one, the air in the duct. This air duct. Air goes through inside. So now we have the water pipe. The water pipe, this one connect to this area, connect to one standard atmospheric pressure, and this area connect to the air duct. So now have the water in the pipe. So the different level of water is water pressure. It's measured water pressure, and how to measure that inches of water column. I mean this length. Okay, that's air pressure measure. And how about water pressure? So now have the water pipe. The water goes through in the water pipe, and this is a small water pipe. This is a closed area. This area is closed, okay? And here have the water. So the water will go up, because have the water goes through in this water pipe, and the water may go up. So this length is feet of head. So we use it to measure water pressure. So this one, I just hope you can understand what's a concept and to explain how to measure air pressure, water pressure. Okay, just make sure you know what's that. That's okay. That's enough. And then let's review heat transfer. So do you remember the three types heat transfer? Convection, conduction, and radiation. And also if you are cooking, this is oven, cold water. So now you want to get hot water. So how to do that? Put the pot on the oven, right? And then the oven is hot, water is cold. So that means heat travels from hot to cold, and then the cold water becomes to hot water. So heat transfer always from hot to cold. And three types heat transfer: convection, conduction, and radiation. Okay, we introduced last week. And BTU. So now just you know what's a BTU. It's a thermal energy unit. And then how about 1 BTU? 1 BTU is about the amount of heat given off by 1 kg match. So this is 1 BTU. And gate capacity, water 1 BTU per pound per 1 Fahrenheit. And here I provide the ice. Ice is 0.5. Air and concrete. So just make sure you know them. Okay, we will use them for this class. And then let's start the new content for this class: sensible heat and latent heat. So previous slides we just reviewed last week we learned, and now let's start new one. Sensible heat causes a change in temperature of substance when heat is added or removed. Sensible heat is the energy required to change the temperature of substance with no phase change. Latent causes a phase change of state in substance when heat is added or removed. Latent heat is energy absorbed by or released from a substance during a phase change from a gas to liquid or solid to liquid. Okay, there's a phase change, but no temperature change. Okay, sensible heat, temperature change, no phase change. Latent heat, phase change, but no temperature change. Let's see. Now let's overview for sensible heat, latent heat. So now we want to melting ice to water and then water to steam. So now heat added, horizontal is heat added, and vertical is temperature. So let's see the ice. So now we assume the ice temperature is 0 Fahrenheit. And then, do you know what's the temperature? The ice melting to water. The temperature is 32. Okay, so now the 0 Fahrenheit ice to 32 Fahrenheit ice. That means phase no change, ice still ice, but temperature change. Okay, because this 0 Fahrenheit ice become to 32 Fahrenheit ice. That means sensible heat. Now we are melting ice. 32 Fahrenheit ice, no temperature change, to 32 Fahrenheit water. Okay, ice become to water, but temperature no change. This is latent heat. Again, 32 Fahrenheit water to go to this one, 2.2 Fahrenheit water. What's that? Temperature change, 32 Fahrenheit to 212 Fahrenheit. Temperature increase, but water is water. This is sensible. See, ice is ice, temperature increase, sensible. Water is water, temperature increase, sensible. 212 Fahrenheit water. 212 Fahrenheit steam. Temperature 212, temperature 212, temperature no change. Water is becoming to steam. What's that? Latent heat. And then 212 Fahrenheit steam, temperature increase, maybe go to 300 Fahrenheit. Temperature increase, steam is steam. So this is sensible heat. So it's an overview how the ice become to the steam. Okay, let's see. Between 32 Fahrenheit and 212 Fahrenheit in the liquid state, the temperature change is raised with sensible heat. Water gains or loses 1 BTU per pound per Fahrenheit. What's that? The heat capacity of water is sensible heat. How about latent heat? 32 Fahrenheit when you are changing phase from liquid to solid. Freezing water lose 144 BTU per pound of latent heat. At 32 Fahrenheit when you change phase from solid to liquid, melting ice gain 144 BTU per pound of latent heat. No degree F. Why? Latent heat no temperature change in latent heat, so we don't need to consider delta T. But at this time, the C 144 BTU per pound because phase is changing, so C is 144. Okay, so this is latent. Okay, let's see example. A block of ice 0.5 cubic feet in volume is taken from freezer where it was stored at 32 Fahrenheit. Density of water or ice is 32.41 pound per cubic feet. How many BTU of heat will be required to convert the ice to water at 75 Fahrenheit? Let's see the steps of the ice to water. Now, it's 32 Fahrenheit ice. we want to get 75 Fahrenheit water, right? So they should be have the two steps. One, 32 Fahrenheit ice to 32 Fahrenheit water. Phase change, but temperature no change. What's that? Is latent heat. 2. 32 Fahrenheit water to 75 Fahrenheit water. What happened? This is sensible heat. Temperature change, phase no change. So how to calculate total BTU? Q latent plus Q sensible. Okay, this is a whole step to for the solution. Let's see detail how to calculate latent and sensible. First one, whatever for latent and sensible. Like again, latent is C by M. Sensible C by M by delta T. Okay, C 144 M. So now let's see what's M. Okay, it's 100 lbs. Okay, this is M mass. And then latent, what is Q latent? By C is 144, is latent. What is sensible? C is 1. What is T? 75 minus 32. Okay, so we can get sensible, we can get QL, latent. So plus both of them, you can get the total thermal energy. Let's go here, C latent, C is 144, no temperature change. We got that. Sensible, heat capacity of water is 1. Mass C 1 delta T 75 minus 32. Okay, and then plus. Okay. Plus both of them. Okay, that's all of the information for sensible heat and latent heat. So hope you got a fully understanding of that because you have a homework to cover this. And then let's go to terminologies. So I want to introduce some terminologies for HVAC fundamentals. So now, do you know what is a chart? It's a psychrometric chart. So usually we use it to help us to understand what's a comfort zone to design HVAC system, to like design comfortable temperature, humidity for the HVAC system. So now let's see the psychrometric chart. You can find this one, dry bulb temperature, and then humidity ratio, relative humidity. So a lot of items on the chart. Let's see what of them. First one, temperature. So what's the temperature? So if you open your weather app on your phone, you can find the temperature. Usually this is dry bulb temperature. Go back, dry bulb temperature, okay? This is temperature. And also Fahrenheit, right? It's a US, always use Fahrenheit. Like in my country, we use this one. Dry bulb temperature, this without the consideration of humidity. So what is the wet bulb temperature? It's a temperature a sample of air would have if cooled to saturation by evaporation of water into it. So measure of cooling resulting from evaporation. and humidity, easy understand the amount of moisture in the air. And relative humidity is very important. It's very commonly used in the psychrometric chart. It's a ratio of the actual amount of water vapor in the air to the maximum amount of water vapor the air can absorb at the specific dry bulb temperature. 100% relative humidity means saturated. Dew point. It's very common. Dew point. Point where air cannot absorb moisture, 100% relative humidity. C is saturated. Temperature at which moisture begins condense. Okay, absolute humidity, pounds of water per cubic foot of air. Specific humidity, the pounds of water per pound of air. So this all is for to support you to understand what's a psychrometric chart. And then let's see the psychrometric chart. Now, the given information is 80 Fahrenheit dry bulb temperature. Vertical is dry bulb temperature. Okay, 80. Go up. Sorry, it's not straight. It's 8. Humidity ratio. See, humidity ratio. This line. Okay, 0.012. So this line. And what's the relative humidity? The curve. The curve should be. Sorry, it should be 55. Okay, 55%. So based on the two number, you can get a point on the psychrometric chart, and then you can get the other number. Like dry bulb temperature is vertical, the humidity ratio is horizontal, and then you got the point. So relative humidity is a curve. It's this curve. So you can get the relative humidity. And then example, the red one, the red line, 75. Okay, this is 75 vertical. You got the curve. Curve is 32% RH, relative humidity. This is a curve. So you got the point. And then the horizontal one, 0.012. This is a humidity ratio. And for the blue, the dry bulb is vertical, 78. And RH is 52%. You got a point. The horizontal is this one. Maybe 0 or 0.111. So just give the wrong number. So now we got the energy. We know energy form. We know sensible heat, latent heat. We know some psychrometric chart as for HVAC design. So now let's see what is HVAC system. H is heating, V is ventilation, air, and C is conditioning. So goals of the HVAC system controls temperature and humidity, fresh air circulation, air filtration, efficient and economical. So this is introduction for HVAC system. Here is overview of the picture of the HVAC system. So let's see what's a main component of HVAC system. Let's see. This area is water. It's a water system. This area is air system. Do you find? So this is water. Okay, this line is what go supply or return, is water. And this one is air duct. This air, right? So let's okay, go. Yeah. So now let's see. The first one, the outside air go inside. And what is air? Go inside. This is return air. Return air from the indoor. And then mix right here, mixed air. So why we mix the return air? Usually we know outside, like during the summer, outside very hot temperature, and indoor air is cooler than outside. So if we use all fresh air, that means we have to the cooler the all fresh air or the hot temperature air. So that means we have to use more energy. But sometimes we can just use a part of the return air from the inside mixed with outside air, and then we can get the heat transfer between of them to get economical goal of the HVAC system. So this very common HVAC system design for typical commercial building to get the economical efficiency. And then let's see the other one, like this one is a heating coil, cooling coil is connected to the water system. So the air will go through the heating coil, cooling coil to get a conditioning air. So the air should be comfortable, and then use a supply air duct to supply air. This is supply diffuser. How about this? It's return diffuser. So part of them return go back and then mixed in this area. And this is easy to understand. Usually we put restroom, so exhaust air. This is air system, and water boiler and the chiller, condensing water return in this area. So this water system that will provide heat transfer with air. Okay, so the part of component of the cooling tower, chiller, boiler, and some water pump. So that's a main component HVAC system. And now, why we need to use HVAC system? We want to get a comfortable indoor air quality, comfortable indoor environmental quality. So what's indoor environmental quality? Healthful indoor air quality, thermal comfort, and visual control, good lighting, connection with outdoors. What's indoor air quality? Contribute to the comfort and well-being of building occupants by establishing minimum standards for indoor air quality. So if you want to find the we should say these codes, design codes, you can find the book. You can find this book. So for this class, because we don't have enough time to go through all design codes from the book, but if you are going to consulting company, if you are design HVAC system, you have to use it. Like the 32.1 is for ventilation for acceptable indoor air quality, so you can know what is design air speed, air flow for the different type room, different type of buildings. And also here have the AirShare standard 55. This thermal environmental conditions for human occupancy. Like for example, like this room we have 100 people, and that room we usually design for 50 people. They should have the different code, and they have the different the operation design of HVAC system. You may select the different type of HVAC system. So how to decide, how to determine that, you need to use codebook to do that. So for this class, you don't need to remember all of the design requirements, but I hope you can know how to find it. So AirShare standard 55 is thermal environmental conditions for human occupancy. AirShare standard 32.1 is for ventilation and acceptable indoor air quality. And then we know comfortable, like why we need to use HVAC system. We say the goal of is let us get healthful indoor air quality, we can feel comfortable. So how to make sure we feel comfortable? There are 6 factors: air temperature, air speed, humidity. This easy understand. Radiant temperature, what's mean? Usually this close to window, if especially like afternoon, if I sit close to window, have the sunlight, natural light directly, like going to my eye, I cannot see clear on my PC screen. So this eye glare. And also, I feel my arm close to the window feel very hot. So this is a radiant temperature. If it's very high, it's not good. So we need to consider this radiant temperature. Maybe we can use a shading. We can use like uh, some operatable window to adjust it. And that's one like we already introduced like in our first class. So for the gym, for the classroom, for the PC computer room, you really have the different design, different the HVAC condition design, and clothing. Okay, for lab, in the lab, usually we have to wear the long t-shirt, but for the normal classroom during the summer, short t-shirt that's fine. So for the different types of the room or building, they have the different clothing requirements, so we have to consider. And also like during summer, during winter, we have the different clothing style, so we also need to consider they may affect human thermal comfort. So here is a thermal comfort zone. You can find winter and summer, they have the different comfort zone. And this photo is part of the psychrometric chart. You can know the curve is relative humidity, horizontal is humidity ratio, vertical one is drive up temperature. So now comfort in summer, temperature is up to 79. Okay, this is vertical one, 79, and the humidity up to 60 RH. You see, so we have to select this area at the summer comfort zone. And for winter, temperature is down to 68 vertical, and humidity is down to 30 percent RH. Next one. So the winter comfort zone, we can choose this area. This is comfort zone for the summer and winter. And then here is I already introduced like airflow, we know the airspeed, radiant temperature. Usually we need to consider some space close to window. And then like the metabolism, different types of space have different requirements. Gym, classroom, you really have the different design. And then I want to say the humidity ratio. Do you remember in the psychrometry, the horizontal, that's mean humidity ratio. Okay, is the ratio of the mass of the water vapor to the mass of the dry air contained in the sample. So Asia 55 2023 identify less than 0.012 humidity ratio, less than this number. This is thermal environmental conditions for human occupancy. So we always need to make sure humidity ratio less than this number. Let's see, like this psychrometric chart. So this one is humidity ratio. So do you know now the temperature is 70? So can you tell me what is the relative humidity? It's this one. Okay, 75%. Humidity, relative humidity, how to less than 75%. Okay, because human humidity ratio how to less than 0.012. Humidity ratio, a relative humidity, that's one. So we may choose this area as a comfortable zone. Okay. This is all for today's class. Review concepts of energy and sustainability, energy form, the heat travels from hot to cold, 3 types of heat transfer, and then second one, identify sensible heat, latent heat. Make sure you know how to do calculation for them and understand essential terminology in building mechanical systems. So psychrometrics, make sure Once you got the two numbers, two items of the psychrometric chart, you can get a point, and then use this point you can know the other items and identify component of HVAC system, water system, air system. So make sure you know what's the main component of this system and understand principles of comfort design in mechanical system. Okay, so why we need comfortable indoor area is for health, right? And also how to identify any factors affect the comfortable. 6 factors. Okay, and any code books you can use to design HVAC system, Azure 32.1, Azure 55. Okay, make sure you understand everything and then complete homework 2.